Okay, in this problem, it wants you to determine the margin of error confidence interval to estimate the population where n is 44 and the standard deviation is 45. And we want to do the 91% confidence interval. So here is your formula. So you're going to find z, and they want you to find z in the table, and your standard error times your standard error, your mean, which is the standard deviation divided by the square root of n. So first you're going to figure out alpha, and you're going to divide it by 2 and subtract that from 1, and then you're going to look for that in the table. So I'll just pull up my whiteboard and work it. So our margin of error, the formula again is just z, your z value times your standard error, and your standard error, to get that, you do the standard deviation divided by the square root of n. So to find z, first we take our alpha, and this is 99%, so alpha value would be, no, 91%. So alpha value would be 1 minus 0.91, which is 0.09. And then you're going to take that and divide it by 2. And that's going to give you 0.045. So you're going to say 1 minus 0.045, and you're going to get 0.955. So this is the tricky part. When you go to look in your table, you got to find the closest number to 0.955 in this table. So 0.955 would be in between, it would be in between 9.554 and 9.545. So think about it. 9.545 would be a little bit less than 9.55. So it's going to be somewhere in between 1.70 and 1.69. Okay, so let's think about it. 0.9, let's say 1 was 0.9545 and the other one was 0.9554. And our number that we got is 0.9550. So if you look at that, you see that 9550 would be, there's a difference of like 5.005 here. Let's see. So 0.005 here, and then this one is a difference of 0.0. So this number is almost halfway in between these two numbers. So what we could do is just average these. So get an average of those two numbers, and that will give us really what we want to use, divided by 2. So 0.95495 is a good critical value there. So 0.95, I forgot what we said, 0.95495 is going to be really close to what we need. And then times, this is what we're doing, and to get the standard error, we're going to do times the standard deviation, which is 45, divided by the square root of 44. So let's do that. I know I got a lot of numbers here. Let me get some of these out of the way. So let's take, first let's just put in we already have this is our number for Z, so I'm going to remember that, and I'm going to do over here equals, I'm just doing the standard error, the standard deviation, which is 45 divided by the square root of 44. So 45 divided by the square root of 44, and yes, we'll add a parenthesis. All right, so now these are our two numbers. This is the Z value and this is the standard error, so we need to multiply those together. So this times this, and something's off there. Let's see what we did wrong. Oh, okay. So I don't put 0.95495. I forgot to get the Z value of that. So the Z value is going to be halfway in between 1.69 and 1.70, halfway in between those two numbers. So I got the average of the wrong thing there. So I want to do equals the average of the Z value, not the probability. So 1.69 plus 1.70 divided by 2. So that would be 1.695 for my Z value. So this is what this should be. All right. And then when you do that, you end up with 11.498. So that's going to round up to 11.50. Let's look at that. Okay, and then for 95, we could do the same thing, except this time we're going to get 0.05, and then 0.05 divided by 2 would be 0.025, and 1 minus 0.025 would be 0.975. Now I need to go look that up in my table. Now the other part, the standard error, is going to stay the same. So if I look up 0.975, 973, and 978, so it's going to be almost halfway in between these two numbers, and that's going to be 2.04 and 2.05, I think. Yeah, 2.04 and 2.05. Let's say halfway in between there, approximately. But if we take the average, 2.04 plus 2.05, and divide it by 2, we get 2.045. So let's use that times this, and we already have all that in there. So let's say the Z value times the standard error of the mean, which is this 6.78405. So we end up getting 13.87. Let's see if that's right. Okay, we're off a little bit. Let me check my calculations here. 0.975. Let's look that up one more time, and it could be .975 is okay. So 0.975 is in here. It's at 1.96. I don't know what I was looking at. So I'm making a lot of mistakes today. My brain is tired. So 1.96. So I don't know where I was looking. Let's try that and see if it works. So this is going to be 1.96. So 13.30. Let's see if that works. Okay, that works. So I hope this didn't confuse you. We can do the 98% real quick since I have it pulled up. So that's going to be an 8. And that's going to change that to 0.02. And 0.02 divided by 2 is going to be 0.01. And 1 minus... won't let me erase for some reason. All right, 1 minus 0.01 is going to be 0.99. And if we look up 0.99 in our table, see what that would be. I bet it's in there too. 0.99. 0.9898.9901. That's really close. So 2.3122. Let's try 2.33. So this time we're going to change 1.96 to 2.33, and we're going to get 15.81. Let's try that. It's got to be really close. Oh, that's it. Hopefully that'll help you. Just let me know if you have any other questions.